Hey guys, it's Miss Johnson, and I'm here to bring you our notes for Unit 5, Notes 4. Today, our learning target is on choosing an appropriate method to solve a quadratic. So by the end of the day, hopefully you are able to determine how to solve a quadratic, because there's lots of different ways that we've learned. So just a reminder, when we're watching our videos in class, we want to have our notes sheet out in front of us and something to write with, and probably a calculator. That's usually a good thing to have. And yeah, we'll get going. So up at the top, we're going to talk about the three different methods that we have to solve quadratics. These are all three methods that we learned in this unit so far. So we've talked about graphing quadratics, and we've talked about factoring quadratics and then using the zero product property. And we've also talked about using the quadratic formula. So here's the pros and cons of each of those methods. Now, while graphing is not too bad, it's pretty quick. We can make a graph pretty easily by making a table and putting it on the coordinate plane. Graphing is not always the most reliable method because it's not always the most accurate. You can't always see where those x-intercepts are, especially if they're not whole numbers. If they're between two whole numbers, then it's going to be hard to really determine what those solutions are. Factoring is great. Factoring is when we set up the x and we put, a times c up at the top, and then we put the b term on the bottom, and we find our two terms, split the middle, set them equal to 0, and solve. But here's the thing about factoring, it doesn't always work. There are some things that can't be factored. Even though they have solutions, they can't be factored. So then therein lies the quadratic formula. Now the quadratic formula is this big, whole, crazy, messy guy, but the nice thing about the quadratic formula is that it always works. So even though it's kind of a big, long, messy formula for us to get through, it always works for every quadratic that we have. So those are the three methods that we learned how to solve, and now we're going to talk about what it looks like to use each method. So let's take a look at number 1. It says I have the quadratic x squared plus 9x plus 20 equals 0. And I'm going to solve by using the zero product property, and then I'm also going to solve using the quadratic formula, and we'll just see what the difference is. So remember, for using the zero product property, I want a factor, so I'm going to set up a factor x. My a term is 1. 1 times 20 is 20. My b term is 9. And then I need to find the two numbers that multiply to 20 and add to 9. If you don't remember factoring, you can always look back and watch some old videos. Check out my YouTube page and you can find some factoring videos. Factoring took place in Unit 4. So the two numbers that are going to help me out here are 5 and 4. So then what I do is I get rid of that 9x and I split the middle. So now I'm going to have x squared plus 5x plus 4x plus 20, and that whole thing is still equal to 0. And now that I have 4 terms instead of 3 terms, I can group them. So now I'm going to group the first two, group the last two, and pull out the GCF. From the first one, I can take out an x, leaving me with x plus 5. From the second group, I can take out a 4, leaving me also with x plus 5. My parentheses match, so I know I'm on the right track. And then I put my factors together, x plus 4 and x plus 5. Now, I want to solve this whole thing, so I need to split these two and set them each equal to 0 and solve. So x plus 4 equals 0. That means I'm going to get x equals negative 4. And then x plus 5 equals 0. Subtracting 5 from both sides means I'm going to get x equals negative 5. So my two solutions are x equals 4, or negative 4, and negative 5. Okay, so now that is using zero product property, factoring and solving. Now we can also use the quadratic formula. So when I plug this into the quadratic formula, recognize that my a term is 1, my b term is 9, and my c term is 20. Okay, so if I plug this into the quadratic formula, I have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplifying this, I need to take care of what's underneath the radical first. So 9 squared gives me 81. 4 times 1 times 20 is 80. And I can go ahead and multiply that bottom. 2 times 1 is just 2. I keep going here. Negative 9 plus or minus the square root of 1 all over 2. And then the square root of 1, if I type that into my calculator, or most of us should know, the square root of 1 is just 1. So I have x equals negative 9 plus or minus the square root of, or plus or minus 1 all over 2. This is where it splits. X equals negative 9 plus 1 over 2, which gives me negative 4. And x equals negative 9 minus 1 over 2, which gives me negative 5. Negative 9 minus 1 is negative 10. Negative 10 divided by 2 is negative 5. So again, I get solutions of negative 4 and negative 5. So same solutions, regardless of the method that I used, but two different ways. Now again, it's your choice. Whatever you want to use to solve these, that's up to you. But just recognize that factoring might not always work and quadratic formula always does. So that might help you make your decision. But a lot of times you can see factoring is a little bit quicker. Factoring is a little bit easier for us to do. So it just depends on the kind of quadratic you're looking at. And let's just take a quick peek at the graph. So if we look at our graph here, this is the graph of that formula. If we were to plug this into a calculator or make a table of values, this is what it would look like. Our vertex is this one right down here, and you can see that our solutions are at negative 4 and negative 5. So that tells you those are the x-intercepts. That tells you that the solutions are the same even if you graph it. Let's try the next one. So bottom of that page, or flip over to the bottom of that page. On that page, or in this question, we have x squared plus 10x minus 24. And I want to do both again, solve using the zero product property and solve using the quadratic formula. So if I solve using the zero product property, 1 times negative 24 is negative 24. And my middle term, b term, is 10. The two solutions that are going to give me that are going to be negative 12, no, I'm sorry, positive 12 and negative 2. Positive 12 times negative 2 is negative 24, and 12 minus 2 is 10. So great, I'm going to get rid of the 10x in the middle, and I'm going to go from there. So I've got x squared plus 12x minus 2x minus 24 all equal to 0. Now I have 4 terms instead of 3, so I can group. I pull out an x from the first one, leaving me with x plus 12. And I pull out a negative 2 from the second one, leaving me with x plus 12. So now I've got x minus 2, x plus 12, all equaling 0. And then I split them and solve. So x minus 2 equals 0. That's x equals 2. And I add 2 to both sides. Over here, x plus 12 equals 0. That's x equals negative 12. So two solutions, negative 12 and positive 2. Now let's take a look at the quadratic formula. If I use the quadratic formula, I've got an a value of 1, a b value of 10, and a c value of negative 24. So I plug that all in. I've got x equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Again, simplify underneath that radical first. You've got to take care of that. A radical symbol is like a grouping symbol, like parentheses, so I have to do that first. When I take the square of 10, 10 squared is 100, and negative 4 times 1 times negative 24 is going to give me positive 96. All over 2, negative 10 plus or minus 196 when I add those together, all over 2. And then taking the square root of 196, I end up with negative 10 plus or minus 14 all over 2. So now I'm ready to split these. These go to two different things. I have x equals negative 10 plus 14 over 2. That's going to give me 4 over 2, and 4 over 2 is positive 2. Over here, x equals negative 10 minus 14 over 2. Negative 10 minus 14 is negative 24, and when I divide that by 2, I get negative 12. So again, I have solutions of x equals 2 and negative 12. You can see again that same solutions regardless of which method I used. Here's a picture of that graph. So same type of thing. So my graph was really low here. The vertex came all the way down to almost negative 50. But when I look at the x-intercepts, there's one at 2, there's one at negative 12. So now let's flip over and do one more on the back. On the back, I have 2x squared plus 3x minus 4. and that's all equal to 0. So I'm going to start by trying to factor it. So set up your x here. 2 times negative 4 is negative 8, and middle term is 3. So I want two numbers that multiply to negative 8 and add to 3. Now, if you think of all the things that multiply to negative 8, you've got 2 and 4, you've got 1 and 8. You could do 1 would have to be negative because I need a negative 8. None of those scenarios gives me 3. So this one ends up being not factorable. Okay, so I can't use the zero product property here. Bummer, because zero product property is a little bit nicer to use. But that doesn't mean there's no solution. That just means not factorable. So I still need to see if there's a solution when I use the quadratic formula. I've got an a value of 2, a b value of 3, a c value of negative 4. And I'm going to plug all that in. So I've got x equals opposite of b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a. So x equals negative 3 plus or minus. I end up here with 9 and then plus 32. Negative times negative again gives me a positive. On the bottom, 2 times 2 is 4. So that's x equals negative 3 plus or minus the square root of 41 all over 4. And then I take the square root of 41. When I type that into my calculator, it's good enough to use 2 decimal places when you round there. I end up getting 6.40, so I'm just going to call that 6.4 there. But yeah, so now I'm ready to split. So I split these two off. I have x equals negative 3 plus 6.4, and then I have to remember to divide that by 4. And I have x equals negative 3 minus 6.4, and again divide that by 4. So the first one, negative 3 plus 6.4 is 3.4, positive. And then dividing that by 4, I get 0.85. And the other one, negative 3 minus 6.4 is negative 9.4, or negative 9.4 divided by 4. And when I divide those, I get negative 2.35. So those are my solutions there. It's 0.85 and negative 2.35. So again, you can see, even though I wasn't factorable, that doesn't mean there's no solution. It just means that we have to use a different method. If we take a look at the graph for this one, you can see there it's between the two grid lines, okay? The x-intercepts are not on a grid line, so you can tell right away that there are solutions. It does cross the x-axis right here, but they're not on grid lines, so we have to do a little bit more digging to figure out what those solutions are. Okay, so let's just talk about why we wouldn't use factoring, and we kind of already mentioned it, but factoring doesn't work when the x can't be solved. This means that there are no roots, or there are no roots that are rational, or that there is no solution. So those are the two options there. Your roots are either not rational or that there's no solution. When they're not rational, that's when we end up with something under the radical like we had in number 3 where it was the square root of 41. It's just not a perfect square under the radical, so we have to consider taking a decimal and rounding there. When it's no solution, this is a little bit different. No solution means that I had some sort of negative under the radical, for instance, negative 10. If you tried to type in the square root of negative 10 in your calculator, you're going to see that you won't get a solution there because there is no real solution. All right, let's talk about the last question on your page. It says the FHS physics department is having a pumpkin flinging contest out on the football field for Halloween. One team's pumpkin has a trajectory that can be traced by the function h is equal to negative 16t squared plus 72t. Pick a method and find how long it takes to that team's pumpkin to hit the ground. So I right away notice that there are only 2 terms, and I also notice that I can take a t out of both of them. So I'm going to try and factor this. So the next thing I want to ask myself is, can I take anything out of 16 and 72? And I can. Both 16 and 72 are divisible by 8. So I'm actually going to take out a negative 8t. And the reason I'm pulling out a negative is just so that I don't have that negative in front anymore. So that's going to leave me with 2t minus 9, because I took that 72 and divided by negative 8. 72 divided by negative 8 is negative 9. So now that's my factored expression, and now I can take each of those and recognize that you want it to hit the ground. That means it's equal to 0. So negative 8t, 2t minus 9. And I want to split those two. So this is going to be 1, that's going to be the other. So negative 8t is equal to 0. Divide by negative 8, and 0 divided by anything is still 0. So this is 0, which doesn't really make sense for a time, but let's check out our other solution and see if that works. I have 2t minus 9 is equal to 0. Add the 9 to both sides. I end up with 2t equals positive 9, and divide by 2. I get t is equal to 4.5. That makes a lot of sense. 4.5 seconds, so this one's out. This one's going to be my solution, and I know I'm looking at seconds. That means it took 4.5 seconds for that pumpkin to hit the ground. All right, that's going to conclude our notes video for today. Thanks for listening, and I hope that you will come back tomorrow and we can practice some together. Don't forget to go back to Schoology and take that quiz. I'll see you tomorrow.